Okay, so what I'm holding in my hand here is a simple guide that was put together by AR North America. And we have Al here from AR that's going to take us through a couple of the very common elements that you'll hear, which are things like my pump is not getting the proper pressure. And usually it's a fairly simple fix, and the troubleshooting guide that's been put together in this book will help you quickly find the root of the problem and fix it quite quickly. Okay, Al, so first question for you is when somebody calls up and they say that their pressure washer has no flow or no pressure, what would be the first things you start to check?
Okay, with low pressure or no pressure, you'd want to go out and make sure that you have fluid coming through the nozzle. If you have enough fluid going through the nozzle and they're saying low pressure, it's a possibility that the nozzle is worn. It can be worn from two different standpoints. One, just from the friction of the water moving through the orifice, or a lot of times nozzles are abused by being hit on the ground, which could open up the orifice and make it run at a lower pressure. Low pressure can be found in worn or damaged valves. Here you have the valve poppet, and here you have the valve seat. The poppet has various pits along the sealing surface, as well as the valve seat on its sealing surface has pits. Those will not allow the valve to close tightly and form a good seal. So the water will be leaking by, and thus you'll have low pressure. Another source of low pressure is worn or damaged seals. In this case, these are high pressure seals. You have damage on the outside of this particular seal. That's caused by a movement, a physical movement up and down in the cylinder, and possibly an overpressurization or high spike scenario to actually crush the seal a little bit and allowing it to move. In this particular case here, you have a cavitation damage in this seal. It's going to allow the water to slide by the seal instead of trying to go out through the valves. This will all affect your pressure because it will cut back on the amount of flow going out the nozzle. Another source of low pressure is the discharge hose and spray gun. These seem to have the most abuse of anything. They're dragged on the ground, they're thrown on the ground. If you have any leaks coming out of the hose, out of the fittings, you're going to see a pressure drop in your system. Yet another area where you can have low pressure is through your unloader or your regulator. These are wear items. You have pistons that are moving up and down, you have ball and seat assembly in the bottom. You will get wear through those areas because of friction from the water bypassing, and once you start getting slippage by your ball and your seat in these unloaders, the water has an easier path to travel through the bypass instead of going out the nozzle. Therefore, you don't have the adequate flow through the nozzle. You're not going to achieve your pressure. Inlet strainers are another area where you can restrict your water flow going in. Therefore, it will affect your pressure going out. You want to regularly inspect your filters to make sure they're clean. They can get dirty very easily, as you can see with this one right here, and this will slow down your water flow. Another example of low pressure would be improperly sealed fittings. If you don't properly seal the threads on the fittings, there's potential for air to be sucked into the fittings, and therefore you get a cavitation. You don't have a full cylinder, therefore you're not going of fluid, therefore you're not going to have full pressure achieved downstream. As you can see here, that this fitting is a tapered pipe thread. If it's not tightened correctly, there's slop to it and air can get through that port. Another source of low pressure for having a fouled valve. In this case, you can see that there's a piece of debris that's hung up in the valve that will not allow the valve to close, therefore you cannot generate any type of pressure. One other source for low pressure could possibly be a defective pressure gauge. Make sure that the gauge is running accurately. Another possibility of low pressure would be belt slippage if you have a belt drive unit. You have to have X amount of tension on this belt so that it doesn't slip over the pulley. In order to get flow in the pump, it relies on RPM for a given bore and stroke. And if you have slippage on the pulley, you'll not achieve that RPM, therefore you won't have your flow, therefore you're not going to have your pressure. Vortexes design their commercial pressure washers without an attached chemical injector. They offer it as an accessory. The main reason is the passageway in a chemical injector is relatively small, therefore it's going to restrict the flow. At that point, you're going to have friction buildup, and that results in pressure loss downstream. So in order to get the maximum pressure out of the unit, they have this as a clip-on attachment that you can buy for your washer. There's two ways to do downstream chemicals with the Vortex commercial pressure washer. One is with a downstream chemical injector. It simply would put a couple into the outlet of the unit. You'd have your chemical hose going into whatever chemical or soap supply you have, and you would change your high pressure nozzle out to a soap nozzle, which has a very large diameter. Therefore, it'll drop the pressure, allow the chemical injector to draw soap. The second way of applying chemical would be with a foaming bottle. This would go on the end of your lance. Again, it's a quick couple attachment. You can adjust the amount of chemical foam that you want. You also have the ability to change your spray pattern from a 0-degree pattern to a fan pattern to cover whatever your cleaning surface is going to be. In this session, we're going to discuss the setting of unloaders, pressure unloaders on the pumps. Your unloader is also your safety valve. What it's doing is creating a resistance by spring tension, and it's forcing the water to go toward the nozzle and out the nozzle. The nozzle is what builds your pressure on a pressure washer. All the pump does is simply move the water. To adjust pressure, you crank this in a clockwise direction, which would increase the spring tension. You always need to use a pressure gauge when you're setting an unloader for the first time, so you know where you're at. The ideal place to set the pressure is on the head. All pumps are rated at head pressure. Down here is called line pressure. You can set at line pressure if you know the differential between the head pressure and your line pressure. Once you have that number, and that would be supplied by PACE, you'd be able to quick couple a pressure gauge in right in this location and set to that pressure. I.e., if this is a 4,000 psi pressure washer, say your pressure drop is 500 psi, you would set this at 3,500 psi, which would give you 4,000 psi then on the head. This is how to set the pressure unloader on Vortex's prosumer unit. Again, you're going to mount the pressure gauge downstream. Vortex will give you the proper pressure settings for this unit. The unloader is located directly in the center of the head. In order to set this unloader correctly, what you're going to first do is to take the black handle, turn it clockwise until it totally bottoms out. Then you'll remove the top plastic cover, and down inside is a lock nut and an adjusting screw. The lock nut is a 10 millimeter. You can simply use a 10 millimeter wrench to loosen the nut. Once the nut is loosened, you'll utilize the 3 millimeter Allen wrench to do the adjustment. You'll start the unit, turn clockwise to increase your pressure, turn counterclockwise to decrease your pressure. Once the desired pressure is achieved, you'll lock the nut back down, replace the cap, and the unit will be ready to go. The user of the pressure washer, if he wants to decrease his pressure, he can simply turn this black knob counterclockwise, which will lower the pressure, and he can go back to high pressure by turning it clockwise without overpressurizing the system. We were talking about adjusting the unloader and increasing the spring tension to have your pressure go higher or force more water out the nozzle. There are limitations on that, as I mentioned, about creating a high pressure spike by running out of the nozzle to where no more pressure is climbing, but you keep putting spring tension on. The spike that I talked about coming back can be extremely detrimental. This is a case here of a pump that has been overpressurized by this being adjusted to too tight of a spring tension. You can see here that the valve caps are extruded out of the head, and you can even see how they come out. The threads have actually been ripped off of the caps by the head expanding and the valve cap raking itself thread to thread and taking the crest of the threads off. This happened across the entire bottom of this pump, and this can be extremely dangerous because this could become a flying projectile. So be very careful on how you're adjusting these. They need to be done with a pressure gauge. Pressure needs to be dropped by changing to a larger nozzle. High pressure spray nozzles are made by various manufacturers. The one thing they do have in common is they have an industrial standard set. On your quick disconnect nozzles that you see pictured here, you have a red, a yellow, a green, a white. Those colors are industry standard for the spray pattern that they're going to give you. The red is a 0 degree, the yellow is 15 degree, green is 25 degree, white is 40 degree. On the side of each nozzle manufactured, there's going to be a number stamped. And it's going to tell you the spray pattern, and it's going to also tell you the size of the nozzle. The nozzle sizes are an industry standard. In this case, it will start out as 00. That will tell you that it is a 0 degree nozzle. The last number on this particular nozzle happens to be a 30. That will tell you it's a 3.0 nozzle. If it was a 4.5 nozzle, it would be a 4.5 nozzle. You have the black soap nozzle. These are generally made of brass or plastic. They have a very large hole. They're a low pressure nozzle. They give you a very wide spray pattern, around 40 to 50 degree spray patterns, and it drops the pressure in the pump so that you can draw chemical and downstream chemical injectors.
What we've got here is a pump that was sent back to us. We don't really know what exactly is wrong with this pump, so we're going to strap it onto an engine and do a test here to see if it has the proper pressure and flow, and we'll go from there.